I have a wonderful electronic invention I want you to see. It looks something like this.
Hello and welcome to another video. I'm Dave and this is the first time we take a closer look at Unreal on this channel. Houdini and Unreal have great potential working together, and it is time to explore that section.
Oh, it is about time. The kind of nonsense we are going to do.
There's a lot more content for Houdini to Unreal coming, but let's take a closer look at Pivot Painter. Pivot Painter is a tool in Unreal that allows you to read data saved in UV channels or textures to manipulate pivot and rotations of the individual pieces of your mesh. Something where you would usually need a skeletal mesh animation can be done directly inside of the shader. This can save a lot of performance. Now to even start doing something with the concept, I need to give you a rough rundown of the mechanic and how Houdini can come into play. In January, SideFX made an update on the Labs tool to output data to use that technique, and also made a video to explain it. To make sure that you already have the information that was given there, I'm going to recreate the steps to set up the foundation with a different mesh example. But the beginning of this video will more or less contain the same information. You will find the link to that video in the description, and if you have already seen that, you can jump forward with the timestamps. But you can also stay with me and we take it from the beginning. The idea is that you have your geometry in Houdini and want to prepare it that it can be used in a shader in Unreal. So let's create a simple mesh. Since this might interest some Unreal people that are not too familiar with Houdini, we keep it simple. I want a grid of boxes, with each box representing one piece of the mesh. So we create a box and a grid node, and we turn the grid from primitives to points. That allows me to use a copy to points node to place a box on each point. This workflow requires you to have UVs on your mesh, so place down a UV unwrap before the copy. That gives us what we need on the box, and the copy will simply duplicate the UVs as well. This version of Pivot Painter will use the selection order to recognize which piece comes next. This information needs to be on the mesh itself and on the pivot points. In Houdini, we save that on the point attributes. A simple way to do that is by squeezing in a wrangle before we copy the box onto the points. Inside the wrangle, we can use Houdini's coding language Vex to do a quick data tweaking. You can do a lot of that with other nodes without ever needing to learn Vex, much like you can use blueprints in Unreal and avoid C++. But Vex can be fun, I swear. So inside that wrangle, I'm typing s@hierarchy, which means this is a string attribute and it will hold root / and then add the point number to that string. The point number is a number, so I need to use I2A to make it a string as well. Here on the left in the spreadsheet, you can see how all the points now have that attribute with the root hierarchy inside. The copy node is copying all point attributes if they are not specifically avoided, so the hierarchy attribute is automatically transferred, and the points of each box now share one hierarchy name. But that only allows us to map the mesh and the pivot points. That does not tell us the order of the pieces. For that we need another attribute with that information, the so-called selection index. It simply holds the information which piece comes next, starting at 0. Something that sounds as if people use it often, and you can take a bet that Houdini has a node for that. The enumerate node does just that. Tell it the name of your attribute and it counts the incoming type. And in this case, we need to go with points. As many already know, I love to do stuff in Vex. Not because it's better, but because it brings me joy. But mainly I want to show that it doesn't matter how you solve a given task, like counting points in an attribute. Stop thinking about the how, just think about the result you need to get. So here we need an integer counting points from 0. We very well could stay in the previous wrangle and just type I at selection index equals at ptnum. Points in Houdini start with 0 as well, so this would do the exact same thing. In this case, however, there was a good reason to do it after this node, because now this attribute was also copied over to the boxes. This would add an unnecessary step to exclude the attribute from the copy node. But still, understand that in Houdini you can do the same thing in a lot of different ways. In the end, you are simply manipulating data, be it with a node or in plain code. But we still have to do something on the points, which is actually easier with a wrangle. The points need normals, so that Unreal can recognize on which axis pivots are supposed to be rotated on. Type in @n, which is a known name for Houdini to hold the normal, equals set001, which gives every point the same normal value, pointing in one direction. Finally, we create the SideOfX Labs node. This is all hinging on the Unreal Pivot Painter node. For one, there is a difference how Houdini and Unreal look at size. 1 unit in Houdini is 1 meter, while Unreal thinks in centimeters. So the tool directly scales the geometry up by 100. The Pivot Painter 2 workflow uses textures to provide the information. The workflow that I wanted to experiment with uses the pivot positions with their selection order and a texture holding the normal information. By default, this says X vector, and I kept it that way, even though I pointed all the normals in the Z direction. It doesn't really matter. It is the shader in Unreal that finds out where the normals are pointing at. Once I hit export, I get an FBX file and the 2 textures. The namespace of the textures reflect the settings in this node. That makes it easier to handle them later. The grid of boxes is a simple geometry, so there is not much information contained in this texture. Still, it's interesting how this allows Unreal to do what it does with it. But let's finally go there and see how it is applied. If you're starting out with Unreal, one of the first steps you should take is to go to the Learn tab, scroll a bit down, and there you will find the content examples. This is a great source to see how different things work and provide a wide range of examples. And of course, there's also a Pivot Painter example. From this page, you can directly create a new project from this asset pack. I already did that, so I jump over to the library and jump in my own project. Here inside of Unreal, you will find the Maps folder. Each aspect of Unreal is divided into its own map, providing a series of ideas. There are 2 maps for the Pivot Painter tool. The first map contains many examples that use the older approach for Pivot Painter 1. They are still very interesting and offer ideas for the potential that the tool has. The other map, here simply called Pivot Painter 2, has some examples for Pivot Painter version 2, like growing with hierarchy depth or the building of objects, which is what interested me. The good old Fortnite construction animation. One of the other big uses, as you can see in the background, is to bring life into your vegetation. But first, let's look at that build an object idea. We want to make the boxes appear. Bring up your files and simply drag them over into the folder of your choice. This brings up the FBX import dialog, and as already provided by SideOfX, the important settings are what provide the information we want to bring over for the Pivot Painter. That is the vertex color, which we want to replace, and the normals that need to be imported. We also want to convert the scene. Everything else can be left alone. Let's find a place for our grid to add another example to the room. Right here in the corner looks fine. There's one specific characteristic when it comes to the textures. The default settings seem to distort the textures and messes with the data they hold. I again rely on Paul's video where he explained which are the correct settings, so we need to make sure that the compression setting is set to HDR, sRGB is off, and the filter is set to nearest, which seems to have the most effect. We need to do that for the second texture as well. And now we come to the reason why we went to this map to test this. Here we already have prepared Pivot Painter shaders that we can jump in for experiments. I want to look deeper into the build aspect. The magic is hidden behind the material, so click on the magnifying glass at the material to jump to its folder. And here it is, the Build House shader. I'm going to copy it with Ctrl C, go back into my own test folder and paste it in. I can directly drag and drop this material onto my grid of boxes. It's not yet properly set up for that, but there's already something happening. The pieces already materialize, but there's obviously something wrong with it. So we need to tweak some settings. To have a bit more control over the material, let's create a material instance from the Build House shader. This will allow us to override the parameters that were provided. We put the instance into the material slot and jump inside. The first basic information we need to adjust is the amount of pieces our geometry has. We had a grid of 10 by 10 boxes, so we have 100 pieces. Also, the boxes appeared quite rapidly, so we might want to turn down the speed. Let's turn it way down first, like 0.001. That might be way too slow, but we will see. Well, that's obviously way too slow now, but it gives us an idea of how the max rotation parameter comes into play. So if we put that down to 0, we should see that there are no rotations at all. But if turned on, it is no surprise that the rotation looks wacky, since we have not yet provided the correct pivot points yet. The shader still works with the textures that are meant for the house. So now it's time to jump into that shader and start to poke around. And I assume this looks like all kinds of horrifying for some, and business like usual for others. Having spent quite some time in Houdini makes it a bit easier to sieve through node trees. But still, as someone fairly fresh to Unreal, I have to admit it takes a moment to adjust. Luckily, since these shaders are meant as examples, they are very well organized and commented. But the most important information can be found right here at the beginning, the place where you provide your own textures. We want to do that within the material instance, so we promote these texture samplers to parameters. And while you're here, it's a good idea to properly name them, also right here. There's a good chance to mix them up otherwise. Again, I call this the X vector, but only because I called the texture that way. The Pivot Painter decode axis vector that follows is what interprets what normals were provided in Houdini. The second texture was meant for the pivot positions, and now we can jump back to the material instance and override the newly created parameters. Since I only have a limited recording area, let me drag that window to the side so that you can see what I do next and how that reflects in the viewport. Pull over the correct textures into their designated slots. You might think that the pure green texture is somehow faulty, but if you remember, all of our normals point in the same direction. So it makes sense to have this texture show only one color. And as you can see, now each box is placed one by one. The rotation also seems to rotate the boxes themselves, not rotate around a distant point. But it is a bit fast to actually see that. Here you see them with 5 rotations and less speed. I really like this kind of approach. It provides a lot of options with only a little more data than only a static mesh. But so far we didn't see much different from what SideFX already showed us. So let's try something else. I wanted to see if I can change the point where the objects appear from, maybe an external source, like the player. I don't know how yet, but that's why I make videos like this, so that I need to learn stuff and can show it to people. I made a duplicate from the shader and called it Appear from Player. We can again create the material instance right away for easier access to the parameter later. So let's again jump inside the shader and try to find where Appearing from Player might be implemented. Somehow it all needs to come from the textures and end up in the world offset position of the material. Here we get the selection order from the alpha channel, and this monstrosity uses that index to animate the pieces in order. As time passes, the frag node creates a series of infinite 0 to 1 progressions. Those are multiplied with the total number, which makes this block pick one of the provided selection indices. But the starting position from where the object appears is straightforward. That position added here by multiplying it to the result of the sequence animation. That's where we want to create another position. That position needs to be related to the actual position of the piece. The shader already uses that location for the rotations, with this absolute world position. We can steal that for our purpose, but that's obviously not the point where the objects should appear from. We need a tiny bit of vector math for that. We are going to bring in the player's location from outside in the next step. For now we need to define a vector parameter by holding V and clicking on the graph. For easy reference, we just call this location. This will be the player. The original shader used a vector parameter as a fixed position. So a 400 in Unreal's Z-axis means the blocks are falling from the sky. I, however, need a position that is coming from the general direction of the player. But I also want to limit the reach of it. It shouldn't pop in from across the map. So how can we do that? First we need a direction that is pointing away from the world position, directly at the player. To get that we need to subtract the position of our box from our player's position. If we would use the result of that directly, we would get a problem. That vector is as long as the distance between the two positions. So this would indeed throw the box across the whole level. To get control over the distance, we normalize the result. The direction stays the same, but the length of the vector is reduced. Well, in Houdini it's reduced to 1 unit, and I assume that it will do the same in Unreal. But we can see that in a bit for ourselves. That 1 unit would be a bit short to see the effect, so we multiply this direction by a distance that we can define on the material instance. And that's what we can connect to the previous offset location. Let's open the freshly created material instance and again put in the correct textures. And here's the new location parameter. Let's put the right amount of pieces in. Before I start playing with the distance, I should bring in the player location. We can already assign the new material and it should make the blocks appear already in place since our distance is 0 by default. Not a bad effect either. We need to tell the level that this element needs to be updated. You could turn this into a blueprint itself or simply use the level blueprint. So let's do that for simplicity. Depending on what you do with the effect, the tick might not be the best choice. You could think about using timers to handling the effect. But again, this is supposed to be quick and dirty, so let's use the dirty tick. After all, this is a simple static mesh in the level, so I drag the mesh from the world outliner into the graph. Unreal uses a mechanic called Dynamic Material Instance to manipulate shaders during runtime. And that's what we do here. Because a player is moving and his position needs to be updated for the shader. But we need that dynamic instance first. So create a dynamic instance for the static mesh that is behind the actor of our grid. We connect that to the tick event and now we can choose a source material that should be dynamic. That's the appear from player instance. After that we want to set the location, which is a vector parameter value of this dynamic material instance. Type in the name of the parameter you want to update, that location, and finally we only need to grab the player's location. We can get that by getting the player pawn and then get the actor's location for that pawn. The resulting vector goes into the value pin and we're set. Let me once again give you a good look at the graph for reference. A simple step, but yet really powerful. Now with that setup, we can go to the material instance and increase the distance. Let's start with 4 meters. The blocks do appear from a certain direction, but this should be the world center at the moment. We actually need to start the game mode for the tick to update the location with the player. Let's go around the corner and take a look. The blocks seem to appear from the general direction of the player, but it is a bit quick to actually see it. So let's increase the distance and lower the speed so that we get a clear view of how the blocks are making their way. And just really push this value up to really see it. This is a quite interesting effect. If combined with blueprints, this could allow for some interesting animations that, again, are way cheaper than skeletal animations. Also interesting to note, if you want to get a clearer idea of how the shader is modifying the positions, it uses an opacity mask to hide all the pieces that are not yet in their place. You can simply disconnect a pin to that mask and see all pieces at all times. That gives you a fairly weird looking effect, but it gives you an idea what the blocks are doing. That made me wonder how the shader reacts when explicitly not using the opacity mask, wanting to animate pieces of your mesh. That's basically what the trees blowing in the wind do. But how about more mechanical shapes, like these cubes? You could create some kind of machine that looks active. I also tried using a slightly more complex shape, playing with their 2 positions and also trying to use different kinds of normal directions coming from Houdini. So I made a few more test shapes and did a few more iterations on the shader. Some things that I experimented with were remapping the time to a sine curve value that makes the mesh switch smoothly between its 2 positions, and I tested applying the change to all pieces at once. And I also found out how to make sure that each piece does full rotations when switching positions. I go over these examples in a longer version of this video available to my Patreons, but the basic principle stays the same. As always, the Houdini file will be available for them as well. So I hope you enjoyed this first look at Unreal on this channel and are back next time. Cheers!